completed our presentation on graphite. The type of particle in graphite is an atom because the atoms form covalent bonds, so the electrons are only shared, not lost or gained to form a charged ion. I'm going to show you a carbon atom that I made out of clay for a model later. I'm just giving some context. There it is, a carbon atom. Okay, the type of bonding in graphite is covalent. Each carbon atom bonds covalently to three other atoms, all carbon. But because carbon has four outer electrons, one is lost and becomes delocalized. And because every single carbon atom loses one electron, there becomes a sea of delocalized electrons that can move through the structure. That right there is a covalent bond for my model. The structure is a giant covalent lattice or a macromolecule, which is actually quite a deceiving name because there are no molecules in graphite because it is a giant covalent lattice. They form hexagonal repeated shape to form graphene in a single layer, and there are weak intermolecular forces between the regular layers, which hold the different layers together and form graphite. Because these intermolecular forces are weak, they can be broken with very little energy. So if you apply a pressure to it, then the layers can slide over one another because they're arranged in regular repeated layers and also because of the weak intermolecular forces. Graphite does conduct electricity and heat because there are charged particles, the electrons, that are delocalized and can therefore carry charge and move through the structure. There it is, a sea of delocalized electrons. So, the melting and boiling points are very high because of the strong covalent bonds required to be broken in between the carbon atoms. So, a lot of energy is needed to overcome these bonds, which is why they have a very high melting and boiling point. And now I'm about to show you using this carbon atom and the covalent bond. I'm about to show you a small model that I made of graphene. It's not quite on the whole screen, but each of these are a hexagonal shape, and the balls are representing the carbon atoms, and the sticks represent the covalent bonds. In between each layer of these, because this is graphene, there will be weak intermolecular forces, and there are electrons floating about in between, moving through the structure, one for every one of these carbon atoms. Thank you very much for listening to our presentation.